Hello one more time. Let's start webinar about digital transformation for industry. I'm Vytautas Šiožinys, CEO of Energy Advice Company. And today we would talk about digitalization maturity, about digital twin technology, about the digital twin benefits, digitalization steps, and case study, what Energy Advice already delivered to our clients and how clients solved issues. So about Energy Advice, we are technology and consulting company focused on energy intensive industry, and in fact our mission is finally to reduce CO2 emission and reach our clients' CO2 emission targets. We are developers of EA-SAS cloud solution software. It's absolutely created software from zero to overall solution by Energy Advice. And another part is EPSM software for electricity grid analysis and hydraulic. I mean, hydraulic is compressed air, gas, water, heat, energy, ventilation system, and etc. So everything what's related to gas and fluid flow analysis and energy analysis. And also we do energy and technology audits to reach also targets for the companies to increase their efficiency, productivity, efficiency, and reduce CO2 emissions. About digitalization maturity. In fact, what does it mean, digitalization? Most of companies, you have a digital solution like automation, some kind of automation. I mean, microcontrollers, SCADA systems, and all processes usually are controlled by the controllers, tracking some set points. And in fact, how human behave to the system, human usually make impact changing set points from, for example, if it have set points temperature 60 degrees, we can change set point to 59 degrees. So it's quite, it's one level of controlling or digitalization of automation control. Next level was probably 10 years or 20 years ago when we put a general meters like fuel wave, electricity, heat meter, mass meters, flow meters, and etc. With increase of capability of control system, we face it and we see industry also use a multi-variable control, where in fact human packed less to the control, more or less automation level is enough for most of cases to reach your business goals. And last 5 years monitoring system was active, where we put a lot of smart meters everywhere for water, electricity, heat, and etc., and then collected all data to the cloud or somewhere to the servers. And finally, digital twin technology is coming here. What does it mean, digital twin? It's a little bit on top of all monitoring, multi-variable control, general meter, or just control system, or microcontrollers. This system is finally on top, because this is like a mathematical real-time model of your physical system, which is controlled by most of these steps. And when we come back to return on investment analysis, return on investments, of course, on the first stage, we just save energy and probably have production quality, some savings due for the hardware performance. On the second level, probably we just monitor energy consumption and probably make decisions to do something. So the ROI calculated could be only due to our good decision for the investments. Multivariable control, in fact, would save cost of human operation stage. Monitoring system, in fact, save just a cost of human, where you don't need to go somewhere and to write down the smart meters value. And digital twin technology comes here as advanced control, extra efficiency, extra productivity, and prolonging time between maintenance and predictive maintenance solution. So in fact, all these stages give you some return on investment, but finally, all stages for the control and monitoring is just matter of a human behavior. And finally, digital twin is trying to help human to perform better, and this is meaning of a digitalization. What does it mean, digital twin? If you go to the Wikipedia, I copied this text from Wikipedia. This means that it's virtual representation that serves as the real-time, it's very important, real-time digital counterpart of physical object or process realized in cloud. So it's in short, long story in short, it's pure mathematic calculating behavior of physical system in real time and in cloud. So what applications could be and related to industry? It's like technological process, it's like logistic task, it's like human behavior, sort of many applications. For example, a digital twin could be implemented for industrial company, technological process, or engineering systems such as cooling machine, cooling, chiller, ventilation, compressed air. For the equipment like biomass boiler, gas boiler, glass melting furnace, paper making machine, extruders for plastic production, for example, or extruders, other kind of material. Technological process like a distillation, grain germination, drying, grain wood pellets, milk for grinding, PET granulation, and others. So its applications quite a lot. And in fact, it's the limitations is only to understanding how to create mathematics for this process. What are the stages of a digital twin? It's design stage. When we have physical system, in general, we have design of physical system of your industrial company. We have digital simulation, we have planning, we have building and company, your equipment. We operate this equipment and the factory. Yes, and we do maintenance and we do process optimization. You design factory, simulate, plan, build, operate, maintenance, and process optimization. So digital twin probably is applicable for all stages, and for the design stage, you just have virtual project and steps and process are repeated digitally. So for better understanding how your company would behave, you just make step-by-step process and repeat it digitally. And if digitally everything is okay, that means the factory in real life would operate also quite good. For the digital simulation, you do just different scenario. You can do digital simulation in Excel sheet. You make a virtual scenario how your factory would behave. I'm skipping building section because we are not related to the building process, but for the operation process, in fact, you need to data collection for physical system from the smart meters, SCADA controllers, and other metering devices, and you real-time simulation using live data, for example, in digital twin. When we come back to operation, data analysis, in fact, have different goals. It's quality assurance, it is productivity increase, energy efficiency increase, predictive maintenance. Coming back to the optimization, in fact, optimization means that we need to optimize set points, as was very easy example. About the temperature, the question is 60 degrees or 59 degrees. It's what temperature we need, in fact, as a set points. or pressure. It is 1.5 megapascal or it's 1.4 megapascal of set point, and the question is, and it would affect the system behavior and to the yield and efficiency, etc. So operator, finally, all these set points in the SCADA system, in the control system, would be somehow changed by operators. And here we see difference between the responsibilities. Because a technology engineer and technologist is responsible for the set points, and the set points, an operator is responsible for the defining set points at the right time. But sometimes happen that the operators fail to set up right set points on time. And so here's the digital twin technology. Later I will describe more how we assist operators, and automated data optimized set points delivered to control system and controllers. So if we would like to absolutely avoid operators issues, we can deliver automated optimized set points to the control system directly without human intervention in between. So what are the benefits of a digital twin? If you're investing to somewhere and something, we need to understand about the return on investment. So first, it's an IT infrastructure quality increase. Usually when we come to the project, we found a lot of solutions, a lot of configuration of IT, and in fact it would be in general quality increase, security increase also. It's problems inside, so it's security also problems inside. Equipment documentation and specification collection and digitalization. If it's some knowledge is on the paper, when the human go outside from the company, all this paper usually goes out together with this engineer. So it's digitalization, and most critical is documentation update on time. I mean, not only the documentation of installed device, but also documentation of provided maintenance activity also. And equipment operation mode identification. So if we have pump, we should understand how it behaves. So it's operation mode, how it's behave. If we have fan, is it right set point, right mode? If it is refrigerator, if it's chiller, if it's furnace, whatever, right operation modes are very important. Bottleneck identifications could lead you to production decrease and quality decrease and downtime. So recommendation for set points change. Digital twin, in fact, due to recommendation of optimum set points, reduce downtime, increase production quality, etc. Quality assurance, quality parameters, real-time calculations. It's very important to monitor your quality parameters. For example, food production industry, when we have food safety issues and quality related to food safety. If you have some produced plastic or whatever, so you have quality issues, and all these parameters should be monitored in real time. We should identify when the quality reduced and what was the reason, and the digital twin allow us to do this. We stabilize quality through set points optimization in real time, and if we have recipe control in your SCADA control system, by recipe, we can optimize the recipe parameters for recipe control. So productivity increase related to different issues. Productivity, usually if a productivity is related with the yield increase strategy is used. If a productivity is related to energy source parameters, for example, temperature or electricity, some issues, the reasons are identified and set points are corrected. And if productivity is related to planning, overall business digital twin would take place, because we should analyze overall business circuits and control this. But finally, yeah, Calvis, you would get this presentation, PDF file and video. So process optimization, coming back probably fourth time in my presentation, that set points optimize it in real times and deliver it to operators, and operators are responsible just to put the set points, or all the set points delivered automatically to the control system. And statistic difference, we calculate statistic difference between the real set point and the optimum set point. And we know how far the process is from the optimum. And after this, engineer technologist can analyze situation using these numbers and make decisions, and we would assist you also. And predictive maintenance is, we have always OPEX due to operation, and we calculate this OPEX, and efficiency reduction costs are calculated. And trend lines show cost breakpoint. So what does it mean, cost breakpoint? It means that you would understand accumulated losses in euro, and here would be your target to do maintenance, because at this moment losses was you could tolerate, because in euros it was less euros losses, but after some breakpoint losses in euros would be non-tolerable, and you should do some maintenance. And equipment and components influence are described and monetized separately. So we analyze separate equipment part to do prediction of behavior of this component. So here we are, case studies and how digital twin was beneficial to the client. First issue is measure some parameters indirectly. For example, usually in the system engineering system, we have a problem with the flow meters, because flow meters error day by day, time by time deviate from normal error, and you don't understand about the quality of the metering. So we have the case where was no flue gas heat consumption meter. Flue gas consumption, it's interesting. Flue gas flow meter do not monitor flue gas flow dynamics. It's like an issue. So you see flue gas from a furnace, incoming, outcoming flue gas from the flue gas consumer, and heat exchanger. Here is a ventilator for flue gas recirculation. What we had some metered values. It's incoming temperature, outcoming temperature, temperature in this loop. We had fun variable frequency drive. It is frequency from a variable frequency drive in percentage. It's active power in kilowatt. Delta pressure between the input and output flow. And here we calculated flow through the fan. From the recirculation temperatures, we calculated flow inside, incoming flow and outcoming flow. And from another digital twin part, we know density of a flue gas, and so we are capable to calculate incoming mass flow, outcoming mass flow, heat energy consumption, input energy, and output energy. So, and the extra meter installed here didn't show flow dynamic, but the calculations each 5 minutes was done, and we saw how it's changing and when the flow meter is metering incorrectly. So no additional flow meter is required. This was very interesting, but no extra investment was needed. We just took the data from SCADA control system, put it to the cloud, put it mathematics, and this mathematics calculated additional extra values, which was used for the technological process. Another case is cooling machine. In general, cooling machine, when we observe cooling machine, we should take into consideration condenser performance and condensing pressure optimum control or pressure temperature. It's related parameters. Evaporator performance and evaporation pressure and optimum control, cooling energy balance in real time. In fact, if we have cooling agent like water, we can have flow meter and understand the energy flowing, cooling energy. But if we have ammonia or freon, we usually don't have mass flow meter. And if you don't have mass flow meter, in fact, we are not capable to calculate energy balance in real time. We just understand electricity consumption from the electricity meter side, but absolutely we don't understand what is a cooling consumption, and we don't understand what is the coefficient of performance. So with a digital twin, we capable to build energy balance, mass and energy balance in real time. Cooling consumption forecast we perform, so we can understand how your industrial company would consume, your factory would consume cooling. And we compare with real consumption, so we make a decision right now, is it correct consumption or not correct consumption. So we put at some KPIs for the compressor and an overall cooling machine, like coefficient of performance or compressor efficiency. And from these parameters, because we know these parameters each 5 minutes, we can understand about the status of a machine in general, about energy consumption of your factory, and we can maintain, we can plan equipment maintenance. So the key example of a digital twin for the cooling machine, shortly I would describe here, is compressor. 4 compressors. We have 4 compressors, and all data is delivered from the SCADA compressor control system. Here we have one loop. It's 2-stage machine. It's condensing part. It is receiver and ammonia inside. It is -2, 0, -2 ammonia temperature. And this ammonia cool down water, and water is recirculation through pump. And temperature of cooling water is 2 degrees supply, and in this example we return it's real live data, yes, from the November 17 for 2 o'clock p.m. Live data. And yes, and a second loop is compressor. 2 compressors is working to the refrigerators on -20. Second is disconnected, and then another -21. So it's this cooling camera, cool down product, fast cooling mode. So, and we don't have flow meters at all, but we have installed electricity meter for the compressor side. We have installed electricity meter, client has installed electricity meter for the condenser part, and for the pump side of the chilled water side. And digital twin, overall mathematics, was capable to calculate coefficient of performance of a machine, energy consumption, electricity, cooling energy consumption, 3 megawatt, for example, in this case, and 687 kilowatt electricity overall electricity consumption of a cooling machine. So no ammonia flow meter was installed, and the client didn't understand what is a real energy consumption. Probably had knowledge about the chilled water consumption because it's meter installed here, but absolutely don't have understanding about the cooling energy consumption in -20 camera. So here we calculated 700 kilowatt cooling energy consumption. And digital twin allowed us to calculate mass flow. You can see 2,300 cubic meter per hour or 2.9 kilograms per second ammonia flow in first stage. And we calculated COP, and we delivered set points each 5 minutes, delivered set points on the ice set water and for the ammonia temperature and at receiver side optimum, and savings 10%. So if you have near to 1 megawatt momentary value of electricity consumption, you can assume how it would be to reduce by 10% electricity consumption, including today's price of electricity. So coming back to the next example is glass melting furnace. The problem is that oxygen level meter in the flue gas is not installed because flue gas is coming out on 462 degrees range. So flue gas oxygen meter is complicated at that temperature stage. And the air supply to a furnace is controlled by airflow meter installed in the input of before the air supply ventilators, after air supply ventilators. And the problem is that the oxygen consumption inside the furnace is related not only to how to say natural gas burning process, but also for the melting chemical reaction due to ferric oxide addings to the melt material, to the glass and melt material. So oxygen consumption is not only due to gas, but also due to chemical reactions. And finally, before our solution, the client had to supply extra air to the furnace, and efficiency was fluctuating due to extra air, due to this energy and chemical process. And when we install a digital twin, we calculate each 5 minutes the status of a furnace, and we can calculate required excess air to the furnace, and we deliver set points, what should be the gas to air ratio at the controller, at the SCADA system, to in order to have good chemical process and good furnace efficiency. Next process is drying. About the drying, in this example, we have grain drying. It's malt drying for the beer, malt for the beer, and then it's dried. Here we have two screens. One is for the measurement, another for the calculation. Usually, when we do digital twin representation in the cloud, we do the same pictures. You can see here different pictures because these pictures are adopted to the client's SCADA picture view in order that operator and technological guys control didn't have mismatch in visual mismatch between one and another system. So we put absolutely visually the same, and here we put metering value. All data are coming from the SCADA system. Some meters, for example, here is gas burner, it's from the gas meter, and these meters and digital twin installed, and on the right side is calculation. So the idea was the drying was processed by recipe in the control system. Energy consumption and drying duration depend on environmental condition and malt water content before kilning process. So it's quite a lot of parameters which affect efficiency of drying, and energy consumption was absolutely unstable, and duration was unstable. So finally, we installed a digital twin solution, and energy and mass balance are calculated in real time. I mean, usually it's during each 5 minutes. Water removal rate calculated in real time, so we understand how the water is removing, how effectively water is removing from the malt, and what is the speed, which is very important for example, wood drying. What is the speed of a drying process? What is temperature, water level ratio, in order to have good color requirements or match color requirements, and process operator receive optimum control set points from a SaaS cloud solution. He just connect to a SaaS cloud solution and look at the set points, and coming back to the control system, just adjust these according to optimum values. At the same client, we had a good germination process. The germination process was very interesting that the digital twin is capable to do grain germination. It's absolutely biochemical process, but was monitored and stabilized by digital twin, and great. Also germination, the issue was that the germination process is controlled by recipe at a SCADA system, and process quality is not stable and varied from batch to batch, and batch parameters variation is not known. Energy consumption related to process is not known. Relation to the process is not known. So and digital twin calculating mass, energy balance, and growing rate are calculated each 5 minutes, and operator receive optimal set points, how the system should behave depending on the status of a grain and status of the outside environmental outside temperature. So another case is related to biomass boiler, but biomass boiler I would introduce very short here, because it is extra webinar for the biomass boiler, and usually you could have opportunity to review our video on Energy Advice website if you have biomass boiler. I have questions here. What is the principle? Vadim is asking, what is the principal difference between the SCADA automation system and digital twin? In fact, it's absolutely different, because you have SCADA system and you use SCADA system. If you would buy digital twin technology, the SCADA system still stay as it was previously in your company. But the digital twin collect data, real-time data from your SCADA system, from your controllers, from the SCADA, I mean from SQL database or from the controllers directly, in parallel from the SCADA system. But digital twin calculate automatically, like a monitor, like calculate automatically what's happening inside, and give you optimum set points. I mean optimum, what is really needed for you, and these set points you usually put to the SCADA system back. So digital twin is like a system which is hierarchically on top on SCADA system. Clients asking us, prior, are we going to change your existing controllers? Are we going to remove existing controllers and put new ones? No, we are not going to change your controllers. We would use everything what you have. We just put the system on top. So the same absolutely with biomass boiler. We put at all SCADA data from the controllers, from the SCADA system. Build biomass burning, energy flow, energy exchange mathematics, and what we are capable to do, it is to calculate mass, fuel mass consumption, mass energy balance, fuel consumption. We are capable to calculate water content in the fuel calorific value in real time, efficiency in real time, and provide set points for the fuel supply, primary and secondary, tertiary air supply, If you have flue gas recirculation, it would be flue gas recirculation. If you have boiler with a grate, you would provide grate rate set points, how it should be in your system. And your operators looking at our system would adjust your boiler parameters for the best performance. If we have many parameters, we coming back to enterprise resource planning. When we have all your industrial company, a lot of parameters in many different places, what we do, we collect all these data from all your controllers, SCADA, meters, smart meters, whatever, data to one cloud, to one place, and make a relation between these data. For example, previously our client has Microsoft Excel sheet based data flow, and process. The client's process are multivariable, and client is not capable to increase business effectiveness in general. And we put at all this data, and the client do not know how parameters change one stage would affect parameters on another stage. And digital twin separated process. We separate process with different digital twin on different stages, and we put that overall KPI. So each digital twin control separately each stage, and overall KPI is implemented, and all data, SCADA, smart meters, laboratory data connected to the digital twin model to one database. Technological process auditing records, separate tasks where operators fulfill auditing records on the paper by hand. In general, is a problem. And food safety inspection parameters are recorded. If technological parameters deviate from the safety limits, the technological process is stopped and cleaning takes place. And client has extra cost due to extra cleaning and productivity reduction, and client's quality control personnel do not have enough parameters for the analysis. And data is in unsuitable format, and data delivery time is too long for the decision making. So we put it all data to EA-SAS cloud. We put it auditing reports instead of paper by hand to the web through computer, and operator is putting data from to the web, to the cloud. And part of the data is entered by client operator, but the part of the data is automated way collected from the SCADA system. Other part of data is collected and summarized automated way. Yes, from the SCADA and smart meters, and modes and parameters which deteriorate technological process were identified, and the process quality was increased, downtime was reduced, and clients' data analytic and quality control personnel have online real-time data about process quality, production quantity, and prime costs. So, does your company needs digital twin? Probably it's latest slides mine. You should raise a question. So do you have issues related to product quality, and the quality is affected by automation control or personnel behavior? Do you have issues related to production yield and affected by raw material quality due to raw material specification, production yield? Sometime increase, sometime reduce. Are you looking increase productivity through downtime reduction and productivity reduction related to minor or major process failure? And are you looking for energy savings? And are you looking for the OPEX and CAPEX optimization through maintenance cost optimization? If you answer questions to yes, probably we can work together. And how the digitalization we provide? First, we collect the data, do analysis and store data to the cloud, build a model, and you are user of the solution. So, in fact, we are not selling like a software when you buy and you don't know what to do, but in fact, we are selling you service, and we guarantee that the service is working well over time. And return on investment, we calculate as reduction of human errors, optimized process, increase personnel productivity, and reduced maintenance costs. So it's a general rule. And we are working couple examples with whom we are working. And time for a question.